Hello students, it's been a very long time. Today I am here presenting you a video about the derivation of Ke equals to 1 by 2 mb square, and it is related to class 9 course, and from the lesson work energy and power, the derivation of kinetic energy, which I'm going to do today. So first of all, we need to understand this figure. What I have done here is I have considered an object. You can take any objects you like. You don't need to take a circular object. Let the object mass be m, and let it be at rest initially. That means it is not moving. So since it's not moving, its initial velocity u is 0 meter per second square. After that, what happens is, let a force F displace this object by some distance, and let us consider that distance is d. That means the force F moved this object from here to here, and it traveled the distance of d, and the final velocity of the object has reached v. These are just a symbolical expression, nothing more. So I have written here the same language that you should be writing here. So consider an object of mass m is at rest initially, that is u is 0 meter per second square. We'll be using this value later on, so it's very important. Let a force F displace this body by distance d with an acceleration a, which makes its final velocity v. This is the initial part of our calculation. Now the rest part is very easy. Let's move on to the calculation now. So let's begin. We know that work done is given by a formula. Work done, this is formula is force into displacement. So let's just use the symbol F into D. So this is force, this is displacement. We know that force is the product of mass and acceleration of the body, that is m into a into d. So what we have done here, we have written the force as mass into acceleration, ma, nothing more. This is a very common term. Next step, we read some few equations that we read in equations of motion. So we need to revise those two equations here. The first equation is, we read the formula of acceleration, a equals to v minus u by t. We'll be using this here. This is the equation of motion. And next one is, we also read another one equation of motion, that is s is equals to u plus v by 2 into t. So these are the two equations we will be replacing. These two equations will be replaced here. Now you might be wondering, what is s? The s and d are both the distance traveled. So d and s are same thing. So let's replace these two equations here. M is left alone, we don't do anything. In the place of a, we write v minus u by t. By t. Next, d, we write u plus v by 2 into t. So this is what the equation becomes, m into a into d. What we have done, we don't need to include this part in the equation. This changes into this. Let's move on a little bit. Now what we do, look at this. M, when we multiply this, let's arrange this first. V minus u by t into, let's bring the v in the front because that changes into formula later on. Therefore 2 into t. So since this is multiplication, we can multiply the upper part. Let's multiply it. M into v minus u, v plus u into t divided by 2t. Right? So as you can see, tt is cancelled now. Now what is remaining is m. Look at this, a minus b, a plus b. The formula is a square minus b square. So v square minus u square by 2. This is the equation we get. Now I told you we will be using this above equation, the value of u. Look at this here, u is equals to 0 meter per second square. So we'll be using this value here now, and we'll get our final value. Since u is equals to 0, the equations become m v square by 2. This is the final. We get the equation. But what we have done here, we had done work done here. We had this. So we were trying to find out the value of k. So a little bit of language is required here. In this condition, work done becomes kinetic energy. Therefore, Ke is equals to 1 by 2 mv square. This proves our theorem. Thank you, everyone.